The stream will be starting in about 5 minutes. Hello there. And we're going live in 3, 2, 1. Hello, it's Keith here, and good morning, good afternoon, or good evening, depending on where you are in the world. I'm in Japan, and that means it's 5 a.m. in the morning. I've got up especially early because I wanted to do a little live stream for you. My hope is that people in the UK and territories like that will be able to watch this early evening. So hopefully this will be interesting for you, and it's worth the lack of sleep. Anyway, despite that lack of sleep, I'm not going to let it slow me down. What we're going to be doing today is a little bit of programming, and hopefully we'll have some fun with that. Now, if anyone has any questions in the chat, I will do my best to answer them, where, as long as they're vaguely programming related, not answering questions about my shoe size or anything like that. But, if you've got questions about assembly programming or anything like that, your hardware questions, I'll do my best to answer them. But if there's no questions, then generally speaking, we're going to be doing a bit of programming. Now, the kind of programming we're going to be doing today is we're going to be writing a tutorial, basically. We're going to be doing the Super Simple series. This is where we write a single ASM file that does a single task, and we're going to be writing the Sega Master System and Game Gear version of the showing a sprite to the screen. So essentially what we'll be doing is we'll be taking the Hello World example and extending it to show some graphics to the screen by copying some code in from one of the other bitmap lessons I've written in the past. So hopefully that won't be too difficult, because I'm pretty tired and can't cope with anything more than not too difficult. Okay. If that goes okay, we're then going to go back to the Phoenix 256, which I mentioned in my last programming stream. At that time, I couldn't get it working because the assembler I was using just basically didn't work properly. Not so great. So I've got a new assembler, and we'll be starting with the real basics of that, assuming we make some progress with the Sega Master System. Now, the entire stream is going to take roughly an hour and a half, something like that, up until 7 o'clock Japan time, because I've got to go to work then. So pesky work getting in the way of the live streaming, but I apologise for that. Anyway, let's start up and have a look. Okay. Now, I'm using a quite different setup today. I've got my live streaming laptop, which I used for the last video, but it's plugged in a bit more nicely now. We've got it plugged into my 4K monitor, my regular keyboard and mouse, and all of my other hardware. So I'm using my regular microphone now, my regular USB sound card. We've really got everything pretty nice. There's a few slight issues still. The screen I'm duplicating onto both monitors here, and the frame rate's a little bit poor basically because using a cheap laptop to drive almost two 4K monitors is a bit of a struggle. So really I need to turn off the one, but then the screen resolution changes and all of the OBS settings go wrong. And so today we're going to be running a little bit slow, but I don't think it's going to make a major difference because we're not going to be very graphically intensive today. So here's the Hello World example here. So essentially what we need to do now is we need to load up the other example. We need to load up this PC here. We need to go to the Z drive and we need to get sources, and it's called GB GG bitmap test, this one here. It's called Game Boy and Game Gear, but it's actually all cartridge systems. So, and what this is going to do is it copies our character, our Chibiko, which is just here, and it copies that into video memory. So we'll take this line here, and we'll put it into the code down here. We've got our bitmap font. I'm going to take the bitmap font out, but we'll leave it there for now, just in case we need any debugging tools. Get rid of this, we don't need these. And we will need this. We'll just put those there for a moment. We also need fill area with tiles. Actually, we'll take all of that easier. Put it straight in the code actually, now we've got it all. So what we're doing here is we're essentially just sort of taking the chunks of code from the working example and we're putting them into this this sort of skeleton framework for a working program here. Now, I mean, by the way, if you've got preferred time slots that you think I might be able to do rather than this one, please, let me know in the chat, because I don't know what time people like to watch live streams. I'm kind of assuming evenings would be preferable for you, which is why I'm doing this slot. But I've been known to watch them during my lunch break or before work. So, if you let me know what kind of territories you're in, what time zones you're working under, and what your sort of personal preference for doing this kind of thing is, let me know. And also, please remember, if you're watching this before the fact, then tomorrow, around 11-12 hours from now, sorry, I didn't explain that very well. Tomorrow at 12-hour shift, it basically early evening, 6 o'clock Japan time, so that would be the kind of opposite time of day to now. I'm doing another live stream, but that will hopefully be a gaming one where I'm going to be playing the Nintendo Famicom, and I'll be streaming that and I'll be chatting about it. So if this programming kind of thing isn't your thing and you want something a bit more casual, maybe that'll be interesting for you. But it is still going to be I am always going to try and be technical, so I'm going to be playing games and I'll be talking about the hardware as we go, and if I know anything about the games or can guess anything, I'll be trying to explain it, and so yeah, hopefully there'll be a little bit of a technical flavour to it, even if it's actually just a gaming stream, because just because we're playing games doesn't mean there's not technical things we can talk about, and the amount of technical goings on while a game is running is obviously going to be incredible. So I think maybe that'll be interesting. Okay, so this is the part that is actually defining our bitmap as tiles that we can then set to the tile map, and this is the part that's showing that tile map to the screen. Now, what we need to do is we need to have the actual code that's going to do that work for us. So we need to now go to our other file, so bear me a second, so I am just changing the settings on my phone. Okay, that doesn't seem to work. Okay, slightly disappointing. I'm watching my own stream on a phone here just to try and keep an eye on the chat and things, because the chat actually just stopped updating on my desktop PC the other day, and it did actually continue on the phone, and it's only showing top chat, not all chat at the moment, but I can't find a setting to change that. Oh, there it is, live chat. There we go. Sorry, phone interface is very slightly different to the PC, but here we go. Yeah. I have to make sure I watch on my phone, so I've got an earphone in listening in, because I don't want to be accused of boomering the audio, as people seem to refer to it these days. So there we go. So we've got, hello there, Quasar again. Grief, a second visit, very kind of you. So we're going to be doing this simple programming example today, and then we're going to have another attack at that Phoenix 256, hopefully in around half an hour. So we've got source SMS here, and we need hardware tile array. I think we need this. So this is what we need. We need this fill area with tiles command and this define tiles command here. And we also, we've probably got prepare VRAM. And we need get video, probably need all, we literally need the entire program. Okay, we need all of that. So that's kind of the problem with the super simple series. The intention was, I had sort of noticed from seeing how people were programming, asking me questions and things, that often they weren't using my examples at all, really. And in some cases, some say, "Oh, I love your tutorials, and I've written this code," and it was like, "That's great code. You're using the firmware. I never do that." And it's like, well, yeah, however you want to do things is great. But it's obvious that the way I'm thinking, the way I'm teaching people isn't the way they're finding the way they want to work, and they're all more comfortable working. So the super simple series was really a response to that, and saying, well, okay, I understand some people are finding the multi-file structure a bit difficult. I fully understand why, and I also understand some people would like the shorter path to getting the job done than the skipping the firmware path, which again, totally understand. It's certainly not my way, but whatever gets the job done for you, whatever you find enjoyable, that's, we're not writing commercial games here, we're writing for fun. So that's quite substantially not worked. It looks like we've got a problem with our definition of the sprites there. So let's have a look. Whatever works for you is the way you should be programming. So okay, so we've got HL, we've got BC, we're missing our DE here. We're missing our DE. We've also got two of these here, so that's not right. Could be just a 256, isn't it? Maybe not. I said 256, I meant 128. So let's have a look. What are we doing wrong there? Ah, yeah, 128 times 8 times 4. Yeah, it's a memory address. I did have a user comment in my chat, in my comments on one of my videos the other day. They said, "Oh, it's amazing how many systems you know, how many systems you can remember." It's like, no, I'm sorry to I'm sorry to shatter the illusion and pull away the curtain on that one. I can't remember all these systems. I have notes. You know, the code, the stuff on the website. You might think I've written it for you. It's as much for me because I can't remember all of these systems. I have to go back and look at my old code, and it's like, oh, that's how the format of the bitmap data on the Sega Master System is. Oh, I'd forgotten. Just, I can remember one system pretty well. When you get to 2, I can probably remember most of it. When you get to 25 or whatever I'm up to now, it's like, nah. You write notes, you make cheat sheets, you look back them up, and you pretend you know what you're talking about again. Again, I say it's difficult when you're trying to give educational content. You need to some extent to make it look like you know what you're talking about, because otherwise no one's going to listen to you. But you don't want to lie about what you know, because you shouldn't want people to think you're some amazing genius that's beyond them, because people aren't going to try to do the same thing that you're doing if they think that. So I don't like doing what I'm doing now, which is writing code that doesn't work and looking like a bumbling idiot. But I certainly don't like looking like some elitist. I'm some master programmer. It's just not. It defeats the purpose of what I'm trying to do here. I want to tell people, I'm no one special. I'm no amazing programmer here. I'm just some guy who put some effort in. So put some effort in yourself, and you could probably do the same. That's what I'm trying to do. So as I say, I'm trying to balance out the trying to make it look like I know what I'm doing, and being a bit more honest and saying, well, often there's some blagging going on. There's some hours there that the code don't work, which you saw last time. So it's like that. Incidentally, you're probably finding the volume level of the chat, the speaking, a little bit low. I apologise for that, but it's 5 a.m. and these apartments I live in, they don't have thick walls, so I can't jump up and down and scream like a over-caffeinated lunatic, because I'll wake up the entire apartment block. So it's what we're working with today. If you want a bit more excitement and a bit more shoutiness, then you're going to have to catch that gaming stream tomorrow. So anyway, so we've done the advanced version, which is where we show our larger 48 by 48 pixel graphic. So what we're going to do now is we're going to create the simpler graphic, which is just a single tile, and it's just a smiley face. I really need to stop doing Alt Tab all the time, because you get this weird corner icon and it looks ridiculous. So what I'm doing now is I'm going for my sprite editor, and we're going to find that smiley face, and we're going to convert it into the format that this system needs. So load up our sprite editor here. I'm not seeing any questions in the chat. If no one's got any, that's fine. If people are asking them and I'm not replying to them, then it's because my screen has frozen up. Either one of these is perfectly possible. But if people don't have anything to say, that's perfect. If there's loads of people with loads of questions, then no programming will occur. That's fine. If there's no one with any questions, then we'll just program away. That's kind of the point of this stream. It's like, well, it's not just me messing around on YouTube. I'm actually doing work that I needed to do anyway, so it works both ways. So we want to go to Res All here. We want to go to Sprites, and we want to use, which one is it? Sprite 8 by 8. Now, Sprite Editor uses text files, and you probably think, well, what on earth's that about? Well, I know a lot of people like XML, but it just annoys me. So I thought, well, if we use a text file, and specifically it's CSV it uses, we can load it in Notepad if the program breaks and wrecks the file, or if we want to do something really ridiculous, then we can just mess around with it in Notepad or even LibreOffice. And I've legitimately loaded the files in LibreOffice, and done translate where you flip the X and Y, or cut and paste bits out, or search and replaces. You can do that. So that's why I use text file. It's it's easier for me to read than XML, and you know, you've got other tools around there that you can, if you are needing to do something crazy, or if you've messed up, you know, you want to merge two banks of sprites together, you just copy paste the text data out. So that's why I've made that choice. I'm sure people would say, well, you should have used something else, but I'm not a fan of XML, and I am a fan of CSV, and the reason for that is I once wrote a little Japanese study game, and I wanted it to work on my handheld, the GP2X, and the GP2X is a Linux-based system, but I didn't know enough I didn't know enough C++ to do that, and I didn't have time to learn it because I was trying to write a Japanese study game and learn Japanese. So I thought, well, what can I program? And I thought, well, you know, QBasic. I can program QBasic. I could run a DOS emulator and write the game in QBasic, and that's what I did. And I mean, in the end, it was showing Japanese symbols and all kinds of crazy things. And it was the file format it was using was CSV, but because it was Japanese, I was using 16-bit Unicode. The point I'm making is I can write a Unicode decoder, a CSV Unicode decoder in BASIC for DOS pretty easily. It's not complex format. Reading a CSV is very easy. It's not hard to do. I wouldn't have fancied trying to do that with with XML. So that's why I use CSV, because it's like, well, even I can write a CSV decoder for Unicode in the Amstrad CPC if I need to. I'm not going to, I don't want to, but if I need to, I can. And I don't fancy trying to write an XML parser in that. So that's why I make that choice. It's just, you know, if it does the job, it's the simplest thing you can imagine. So so we're going to use this save all bitmap option here. And what we're going to do, we're not going to save to that folder here. We're just going to save it called T in the root of the D drive. So, and then what we need is we need a new snazzy little program, which I've been toying with. This is a new fun little thing I've got called bin2 ASM here. And what this does is it converts a bin to ASM. Essentially, this is so I can avoid using the inc bin command should I feel like avoiding using the inc bin command, which sometimes I do. Essentially, I just want to make the code as simple and obvious and, you know, impossible to not get working as we can. So so what we're doing here is we are converting the file. I just drag drop the file in here, and now I'm specifying the number of entries a line. I can show any format I want. If we're doing 68,000 or something strange, we can change the syntax of the line. And so what we've done is we've converted into here 4-bit planes. That's why I've done 4 bytes per line. We've got 8 lines because our smiley face was 8 pixels tall. And so now we've got a visual representation. We've got line numbers just here, and we've got each byte nicely laid out. So if our viewer, you know, is a bit clued in, then, you know, maybe they can work out what that byte data is doing, and it looks a bit nice. So that's why we're doing things like that. So this is it's something I'm playing with. Just where's that sprite data gone? Here it is. So if we just put this in here and we run again. Right, okay, now we've got our sprite to the screen, but we're doing it in a very, very silly way. So we now need, we're running this grid drawing routine, and that's, you know, completely absurd. So we've got our, what we need here is our get VDP pos here. And then we need to out the 2 bytes to the screen. If we go back up here, where is it? This isn't the usual font size I use, by the way. I scale up the fonts for my videos because some people have had trouble reading them. So I have to scroll up and down a lot and sometimes get a bit frustrated. But as I say, it's just so the viewers can hopefully see on there. I think a lot of viewers, for reasons not quite clear to me, try and watch these technical videos on their mobile phones, which, you know, if that's what you want to do, and that's good for you. But I can't really say it'd be what I'd be trying to view this on. But you know, I guess there's maybe people travelling and they don't, or again, maybe watching on their lunch hour. They don't have access to machines that they can freely use. Maybe they're not allowed to by the company policy or something. But I say it's I wouldn't be trying to watch this technical content by video, because it's just I just want to be able to see it as clearly as possible. But I mean, truth be told, I don't watch this kind of I don't watch this kind of technical content and videos anyway, if I'm honest. I tend to work from documentation, like PDFs and things like that. It's just the way I sort of find it easier to work. But really, these videos and doing this live streaming thing, it's not about I didn't particularly wake up and think, hey, I feel like live streaming today. I didn't feel like live streaming today. It's about, well, what are the ways people are consuming media in the world today, and can I engage with that way that people are consuming media, and give them something that they can learn from. Because truth be told, why isn't this working? Because if they learned in the same way as I learned, they'd have learned. I'm using, in most cases, text files and documentation that's 10 years old, 20 years old, even goes back to in the case of the Neo Geo, I'm using the documentation, the official documentation that was released with the hardware, probably. So there's nothing I'm teaching people that's some revelation. I'm just trying to structure it in a way that's maybe a bit simpler, maybe a bit more honest, and trying to explain the things that I really struggled with, and hopefully that will allow people who had previously been unable to learn these things. Hopefully that'll help them manage it. But as I say, it's for me, I prefer the PDF documentation personally. You can read it at your leisure. You can skip forwards and backwards. You can you can read it when you, as I say, when you're on the go, or when when you've only got 3 minutes to do things. You can just read through a page or two, and you can still get something out of it. But I say I understand that there's a lot of popularity now with regards to. I think these are backwards. I think this and this are the wrong way around, maybe. That's not very good. Yeah, you do. It's quite handy going back over the code like this and having a look at it, because there's been quite a lot of cases where I've either found small bugs, or more often optimizations. When I wrote this code, there we go. There's our smiley. When I wrote this code, I knew Z80 assembly, but there were things. I mean, the bit shifting for multiplication, for example, I knew you could do it, but I'd never really had to dig deep into it. And it was when I did the 6502 version of Grime, the Grime 6502, I had to start really working on that, because porting the Z80 to the 6502, especially on the C64 with its 1 megahertz processor, it was slow. It was so slow. So it was kind of like, okay, well, you're gonna have to optimize everything you can out of this, because what you're running here ain't up to the job. So and so that's what I did. It was like, well, okay, you got to come up with some more creative ideas, and that's the idea of bit shifting a value to multiple positions and adding it to effect a more complex multiply. I'd done the thing of doubling things, but multiplying by 6 by shifting to 2 positions and adding together. Sorry, Quasar, you've asked a question. Long gone are the days of getting professionally printed data books and manuals from the chip manufacturers. Even the processor manufacturers then. I mean, I don't mind the lack of physically printed documentation. I don't need physically printed stuff. I've got some. I think it's fun. But PDF documentation, unencrypted, documentation that you can, copy onto your phone or your tablet or your PC, and you could just flip it open or print it out if you wish and copy paste bits of it out. That's what I sort of like to have. I did see on EEV blog they were looking at some of the old Sony documentation for the original hardware, like the cassette players and things, and it did look incredible. But also beyond my capabilities and requirements, but certainly very impressive to look at. And if one day I had the time to learn that kind of thing, I would love to do so. I had someone asking me they left a comment on one of my videos, and you get this kind of comment. They post on completely the wrong video about completely an irrelevant thing. It was the video was on the links. It was creating sprites on the links, which it's a thing. And they were saying, "Oh, I'm building a computer. Can you teach me how to upload the ROM code to the EPROMs? And they seem to want me to design the video chip." And it's like, okay, well, firstly, interesting choice of video to post that comment on, because there's nothing to do with that. And secondly, judging from the views and view count, you haven't watched any of the video. And thirdly, I can't do any of that. And even if I could, you seem to be asking me to do most of the work for you. So that was strange. Optimizing, yeah. I do like a bit of optimizing. I did, when I was originally writing Chibi Akumas for the CPC, I did start to get the optimizing bug. It was like, you sort of started to get the feeling of, I am going to, today I shall optimize. I've optimized 3 times before, but I'm sure there's more to be squeezed out of this code. Although, if I'm honest, a lot of the time I couldn't see that I'd be optimizing for speed, and I've looked at the Z80 tables. I know what I've written is faster now, but I can't see the difference in the play. But there were other times where it was really important, and it was like, well, I got 4K for this code. It's now 4.1K. I got to squeeze 32 bytes out of this, or I've got to squeeze. If I can squeeze 64 bytes out of it, I can, make the game better, or make the game even run in some cases. And I did. There's something satisfying about it, and also there's I think if you're able to do it, if you've got the time and things, then there's something that helps. When you start writing a piece of code, you're just trying to get something that vaguely works, and then if like with Chibi Akumas, it was my first game, you kind of look back at the thing that barely worked, and I think the first version went at 4 frames a second or 1 frame a second. It was terrible, and then the final version, and you can see the progress you've made just on the screen, and you can see by looking at your own code and just hanging your head and thinking, what was I doing? Why did I write such awful code? Because you've learned more and you've become better in optimizing it and things. But I mean, as I say, it's easy to look back at your own code and think things like that. But the truth is that a good program's one. My strong opinion on this is, a good program is one that's finished and runs, and a bad program is the programmer who laments they ran out of time and didn't finish it. I'm not a fan of this thing of people saying, oh, you shouldn't program in BASIC, you've got to use C, or you've got to use assembly, or you've got to program in this way, or you've got to program in that way. It's like, no, I don't agree with that. What you've got to do is you've got to decide what you want to do and then finish it. Programming in the best way possible and not finishing your project is nothing. That's failure. Programming a slow game in BASIC that isn't as good as it could be, that's still an achievement over the person who didn't finish. So that's just my opinion. I'm not a fan of the elitism you see. People should just program. People should do things in whatever way they are confident that will mean they're most likely to complete their project. That's the goal. It's not, as I say, we're not programming in almost all cases. We're no longer programming for money. We're programming for fun. We're programming for personal achievement, and personal achievement doesn't have those kind of boundaries. if you've never programmed before and literally nothing, and you program a little basic program that says, you know, enter your number and you get a number, that's an achievement that was worth doing. So, you know, it shouldn't be any of this. Oh, basic isn't a real programming language or anything like that, because it's just not. It's not. You know, what's the point of that? What we're doing here? We should be you know, we should be encouraging people to try the systems that we used to enjoy, and you know, also say if people are programming for education, you know, if you've never programmed before and you learn to program basic, well, you're learning mathematical concepts and things there, aren't you? And you're learning, you know, structure of code. And I know people say that basic isn't well structured, but yeah, say, well, again, it's like, well, if this is literally the first thing someone's ever done, then it's, you know, it's a thing that they should be proud of, I think. Anyway, so we've got our smiley face here, and we've got our more complex example here. So what I've been doing is I'm just basically taking out everything. I've taken out the text drawing code here. I think that one's now down to the bare minimum. So let's do the other one. So that's the basic version. Now I think we'll leave this one in with the inc file. You know, we'll include the bitmap as a file here, because otherwise we end up with something crazy like this bitmap font. I was feeling a bit frisky with the inc bin, the converting to text there, so probably not necessary, but whatever. So we've got our sprite there, we need that. We've got our palette data, we need that. I think we need that. I can't remember what the system does if we don't have any palette, but we'll certainly leave it in. So we don't need this. We don't need print char. Don't need new line. We don't need print string. We don't need that. Now, so sort of, I started saying and got distracted before. You know, here the problem with this super simple in quotes series is before we were splitting things up into a header and a footer and a graphics routine and what have you, and now we're not. And so the problem is that you've got this huge hulking file with, you know, dozens of sections all that do different things, and you know, when it comes to documenting it and explaining it on stream, you're like, well, do I really go over the header again for the third time? And you're like, well, I'm not sure. So there's our chibi code. And you know, again, it's like, well, maybe we do, maybe we don't. Palette data here. Can I be bothered to fix the palette? So yeah, let's fix the palette. So we've got our Game Gear version here. I haven't tested the Game Gear version, have I? Better test the Game Gear version. The two, if you don't know, of course, the Game Gear and the Master System are the same machine. They've just got very slightly different graphics chips. And the Game Gear, apart from its smaller screen, is actually superior, which is a surprise, isn't it? You know, they took the Master System, they slapped a smaller screen on it, and they beefed up the graphics chip. I don't know if they were planning on creating a Master System Pro or something later with the better graphics chip. It's only slightly better colours, but that's why the Master System can play Game Gear games, but the Game Gear can play Master System games, sorry, but the Master System can't play the Game Gear ones, because the Game Gear is somewhat sort of superior. I mean, depends whether you prefer colour depth or screen size, I suppose. But it's a shame, because the Game Gears are struggling a bit these. Oh, look at that! The Game Gears are struggling a bit these days because their capacitors all fail, so you have to open them up and like replace all the caps. So I've got 3 of them, and I recapped 1, and I think the other 2 kind of don't work anymore. But I don't. Forget the reason I'm doing these gaming videos on the Saturday is I just don't play any of it anymore. It's just sitting there rusting away all these old systems, because it's like I spend all my time doing this now, which is you know, it feels like the more worthwhile thing. If people want to play games, that's their choice, but I just and I play them, I die, I get angry, and I just think, what's the point of this? And it's like, well, you know, kind of, if you're not enjoying it, kind of isn't one, is there? So, But as I say, the gaming streams I think would be a bit of fun because this kind of content. Oh, there we go, nice proper colours there. These streams are, well, I don't know. I don't know what people like to watch. It's very strange sometimes what people enjoy watching. It's like the Bob Ross videos. I used to watch the Bob Ross videos before I just after I left university. I was unemployed, and I used to watch the videos, and it's quite fascinating watching someone progressively doing something like that. But I never watched them and thought, oh, I fancy painting that. No, I didn't fancy painting that. I just watching someone progress and achieve things. It feels somehow like like you're following the experience, even if it's not one you're doing yourself. And also, I think a lot of the live streaming thing, people are watching them just for the chat, just to hear what someone else's opinions on things are and things. So again, it's like, just want to. That's why I'm doing these videos, just to see if there is an interest in that, in what I can do and what I have to say. And the end game is really just can we teach people a few things that they didn't know about computers and these old classic machines, because, as I've said a few times, just because these machines are pretty old now doesn't mean that the concepts have changed. I was doing some 64-bit disassembly the other day with a debugger, and it's not changed much. You still got all the same concepts here. You've got registers, you've got memory addresses, you've got indirect memory access, things like that. The registers are wider now. They are 64 bits instead of 8, but you're still seeing the same AND commands, the same saving and loading from memory, the same lookup tables. So if you want to debug 64-bit machines, then debug 64-bit machines. But I think most people are going to be looking for something a bit lower down, and these old machines, there's still plenty we can learn from them. And as sort of Quasar said, they were so well documented back then, and even beyond that, a 30-year-old machine, if we don't know about it now, like the Famicom, if we don't know something about the Famicom by now, with all of the people poring over it with hardware debuggers, they've probably x-rayed the silicon and everything that you could possibly need to know about it, we probably know, and everything that we could possibly want an answer to has probably been answered. Every bug is known about, every piece of potential within reason has been identified. So if you're looking to just learn from scratch, the answers are probably out there for you if you look for them. Whereas if you're developing for the latest release of Windows 10 and the latest processor, and it's a 64-bit processor, you're not going to find that kind of information. You're going to have so many question marks about, well, it didn't do what I expect. Was it me? Was it the hardware? Can't find was it the new version of Windows that updated last night? Well, you're not necessarily going to be able to get those answers. You have to wait another 30 years or something like with the old ones. So let's say if we're a beginner, I think the old systems, I think they're worth looking at still. Okay. So we're going to call that a day with the Z80 coding, and we're now going to have another look at the Phoenix 256. Hopefully, good grief, this is slow. I think everything's running okay on this machine. It's just, as I say, I've got this screen mirroring, and I'm using one of these USB-C converters to do the connection of the second monitor, and I don't know how it works. I've heard that USB-C allows a sort of HDMI pass-through or DisplayPort pass-through. I'm using HDMI, but the converter I've got's got a VGA and a HDMI socket, and it says you can use both at the same time. And it's like, well, is it actually a software video card then, or is it a hardware pass-through just with the same HDMI pins that the video card had internally? Because obviously the performance you'd expect to be very different between a hardware video card, even if it's just an Intel one, and a software video card. And I don't know the answer, but whatever, as I say, it's I did try it yesterday and it is slower, but when I turn off the display on the the laptop displays 3000 by 2000, and I've got OBS with the capture window set up for that display. Here's my OBS. So this capture window here is all set up, but if the screen resolution changes, the capture window doesn't point to the right area. So when the screen resolution changed to 4096 by whatever it is, it captured the wrong area, and it's like, well, I'm gonna have to change all the settings. And I thought, well, let's just run both monitors. But long term, I'm probably gonna have to change all the settings and just have two versions, one if I'm only running off the laptop and one if I'm running with the 4K monitor, just to get that extra little bit of speed for times that it becomes unnecessary. So anyway, so here we are now. So this is now my Phoenix 256 example. Now these are the commands that I was trying to run last time that didn't work. Now these square brackets here, using the 0 page, but instead of using 2 bytes in the 0 page, we're now using 3 bytes. This is referred to as a longer address. Now I'm calling it the 0 page. It's called the direct page, but I'm going to keep calling it the 0 page because I get confused by the direct page, because we've got all of these other we've got data page registers, and we've got program page or something like that, and data page just sounds too similar and I get them all mixed up. So we're going to call it the 0 page still. So so we're now able to access 24-bit addresses in the 0 page, and what I'm doing here is I'm modifying that 0 page entry, and that is allowing me to do some addressing of the entire screen area, because the screen area is huge and it's in standard memory, whereas with the other one that's temporarily the Commander X16 just uses 3 6502 memory addresses, and then you use those 3 to access the video memory, whereas this one, the video memory is just part of the main memory. I completely understand why they've done it that way. As I said last time, though, I'm so used to 8-bit, I prefer the 8-bit way of doing things, even though I kind of understand that the 16-bit way, the 24-bit address is better. So I kind of wish they'd use the 8-bit way, but it's not right to think that. So anyway, so what I'm trying to do now is stop talking long enough to actually think, and then if we go to basic macros, maybe. So with the Z80, with the 6502, sorry, what I was doing is I was defining these sets here, and these are Z80 simulations. So if I want to use a source address, I'll use this ZHL pair here. I'll define them, use these, and if I want to do a counter, I'd use these, and a destination, I'd use these, and if I need to back up the accumulator or something, I'd use those. So what I'm going to do here, I'm going to take these. Now, I've had to use all these different commands here. Let's actually just have a quick look at my compiling file here. Where is it? So if we go to utils, I'm not using ASW. ASW has been kicked to the proverbial curb. But I think I'm actually using the same file still. So here's my Phoenix file. So we're using WLADX now. And what this is, the reason I've chosen this one, the people on the people generally programming this system are using this 64T ASS. It works fine. Now my only problem with it was that it doesn't support the if-def statement. It doesn't support it, and they've said we're not adding it, which is not fair enough. But if I'm going to convert the idea is I should be able to convert my original 6502 code to this system, and without that command, the entire way I work is going to be a bit difficult, because I often use are we building for the SNES, the BBC, the whatever else, and they were saying, oh, you have to define them as 0 and then compare them to 1, and it's like, well, yeah, okay, but I'm converting code. So instead I've gone for this WLADX thing here. The reason I chose this one is this also supports the SPC 700, which is the sound chip of the Super Nintendo. So if there's interest in that, and I decide to do that later, at least I don't need to learn another assembler. So so that's what we're using, and basically the syntax is all the same. We just have to put a dot in front of everything. The only thing that's a slight pain, And again, it's like, well, yeah, it's clever what you've done, and you're right to do it, but I do everything myself, you know. So what it does is it works out the fact that, well, okay, this machine only uses 16k banks, and the 16k banks always start at hexadecimal 4000. So, you know, if you've got a 32k file, I need to split it in two and change all the addresses accordingly, and then the ROM file will work, and it does all of that for you. But the way I program things is I say, well, I want a flat file outputting. I know that my second 16k bank, the memory addresses will all be wrong, so I subtract the offset that I know it's going to be loaded into memory. That's what I've done with Chibi Aliens, because sometimes the destination in the ROM file or the data file that's loaded into the program memory, I might switch to different bank areas anyway in the final system with software. So, you know, what area it's in the ROM file and what area it's in actual RAM when it comes to accessing it may not even be the same at multiple points in the same program. So, I say, very clever what you've done, but I kind of usually I take the responsibility for working that out myself. But anyway, so far doing this basically disables that functionality, and through using this I've been able to get my classic Super Nintendo example, which just shows the debugger which I showed last time. I've got that compiled with, and all I had to do is do a search replace, change, add dots to basically all the commands, add this org A instead of an org because that works better, and it's case sensitive. So that's the only other change. But again, I just did a batch search and replace with finding files, and you know, I got it working in about 30 minutes to an hour, which, you know, there were no bugs. It was just search replaces. So, you know, I can't really complain about that. So anyway, I've done a lot of talking there and very little programming. So what we're going to be doing here is, firstly, we need to define a dot equals z regs. We are case sensitive now, so we've got to be a bit more careful than our usual sloppy coding. So we're going to define zregs as being hexadecimal 20, and that's the start of these registers here. And we're going to add an extra one called hx, which is our extended h register. So this is the 20. This is the third byte of our triple here, because now we're working in 24-bit addresses. So we're just extending all of these by one extra entry. So we need 0, 1, 2, 3, 4. No. What am I doing wrong there? I'm doing it wrong. 3, 3, 4, 5, 6, 7, 8. So that's what we want to do there. And now if we put that in here, and we put this to H, and we put this to HX, and then we do this. Now to HL, now of course it will actually be using HLX in this case, all three. And if we run again, it's a little bit slow starting up. Oh, it's also starting up off screen, but I'll bring it to the screen just as soon as it does. Here we go. So now if we go to restart here, now all our program is doing is I'll just get it down here, is it's defining a memory address here with this triple here, and then it is writing to some of the memory here, and I guess it's writing forever. But effectively what it's doing is it's filling this area here. Now this ZHL command though, where is that? Where is that? Oh, actually, no. It's just in. That's a bit weird what I've done there. It's incrementing the low byte only, so it's writing 256 bytes. So this is this here. That's what it's doing. So okay. So we got these here. So we got this push pair, load pair, all this kind of shonky stuff. These are my macros just to make things a bit easier for me. So what I want to do now is I want to do a load triple. And this could be tricky because I can't remember the command. It's a shame, isn't it? Do I have my documentation? Utils, Willadex, WLA documentation. Why are you trying to? Well, why are you trying to go to the Microsoft Edge page when you're supposed to be browsing a local file? Yeah, I'm hoping one day my hatred for Microsoft products is going to build something up telekinetically and just wipe them all out like Carrie or something. Everything they do pisses me off these days. I'm really unhappy about having to use Windows 10 here as well. The only reason I've done it is I can't get a setup this complicated working in Linux. I'm just not skilled enough. So it's kind of like, well, I either do this in Windows and get it done, or I play a stubborn Git and try and do it in Linux, and it probably won't work, and it'll probably be a crap live stream. So I am swallowing my proverbial pride and using Windows 10 here, so that I can actually do this stream. So my pride is not well, my pride is mostly gone already anyway, so it's no major loss there. I can't remember what the blooming statement is. It's is it? I thought it was. When you want the high byte, you use a greater than, and when you want a low byte, you use a less than, and when you want to look at a HTML, I guess you don't use Firefox. What's going on here? Oh dear me. What are you doing? I wonder if this is the video card problem, that everything's just being slowed down by the video card. Oh well, very disappointing there. Okay, well, I'm going to take a guess. I think it might be that. I also shouldn't have closed the emulator last time, because now it's taking ages to start up again. You don't need to, and I can't, at the moment, I can't figure out a way of getting it to automatically load the program and start up and run it like I do with my other systems anyway. So, okay, so let's just move that out of the way. So, if we now use load a triple, and $B02000, get all of these out. Let me run this now. Okay, well, yeah, that wasn't very smart. It still runs, but I can't really confirm whether it's actually it's actually still running the old file or something. So okay, it looks like there's a bug in my code and it wasn't running properly, maybe. Okay. Sorry, when I say there was a bug in my code, I mean the batch file that loads the program up. It looks like it was stuck for some reason. It's not supposed to load two emulators. Oh God, this is running slow. Firefox is still doing something. Where's all my CPU power gone? What's using it all? Desktop window manager, I bet that's that second screen. I bet it's not helping things. So if we do restart here, I'll just get it. Okay, I think that's moved. If we just move it again. So yeah, things are taking a long time with this emulator. As I say, this machine, you know, I can't criticize it. It's doing a nice job of this old live streaming, but it is very noticeably slower than my my other machine. My other machine's an old i7. It's, you know, it's a good 5-6 years old now, but it's got 32 gig of RAM and it's got 3 SSDs. So it's not a machine that you ever see slow down. You know, even if I load up 3 or 4 virtual machines and I make it do all kinds of crazy things, it's only if I suddenly decide to do any 3D gaming I would ever notice that it wasn't the fastest machine on the planet. I'm not sure if that's working or not there. I think maybe it is. Anyway, so we're loading in this triple here, and then what we're going to need next is the ability to increment the triple. So if we load up basic functions here, and if we emulator's finally started, convinced that's working right. I wasn't expecting it to look like that, so maybe it's not working. We'll find out though, I think, in a minute. So if I've got all these commands here, and what I want here is inc.hl. Okay. So effectively all I'm doing here is adding an extra branch if not equals, so that this is now working in 24-bit, not 16. So we've got H, L and HX now. So what this does is it increments the low part, and if there is no carry, then we're finished, so it jumps to here. Then it increments the high part, and that will effectively cope with any carry, and it jumps if there's no more carry. If there is any more carry, then we increment the third part. So this is a 24-bit increment here. So we just jump. We need to move this down the bottom. I'm putting this isn't a macro, I can't put it there. So this is going to do our inking, and so now we can do JSR inc HL here. But this is an infinite loop, so if we run this, we're going to see some crashing because it's going to fill the entire memory area. Let's do it anyway. Let's see some crashing. Give the emulator some punishment for taking so long to start up, shall we? So, going to do LDX of 255 here. While the emulator's starting, we'll start writing our next example. And we're going to do dex. That's a command, isn't it? Yeah, I think that's a command. And then our infinite loop down here. And we do BNE fill again. Yeah, I can barely remember the 6502 commands after doing that Z80, let alone the 65816 commands. I might have to grab my cheat sheet. So, something's not right. That's the exact same code there. Looks like we're just running the same example over and over again. It's quite annoying. That file's updated. Okay. I don't know whether we're opening an old version of the file or something. As I say, that last version I was expecting to crash. So we got our file here, dated 6:17 AM here. That's now. So we'll load that in. Now emulator starts, and then if we do window reset restart. Yeah, it's an old version. That's not the new version. It's still doing the inc of 20 there. Okay, so what's going wrong here? So we're running. It's still called ASW Phoenix, but it's not the Phoenix. Why is that .txt? That should be build. That should be O, shouldn't it? Let's try again. It's a bit of a rock and a hard place with all of this, you know. Is there any special reason why you're using Notepad++? Well, I just like Notepad++. It's simple. It does the job. It doesn't need installing. You know, this is a different machine. I usually program on my desktop PC. I just copied the folder onto this, loaded it up, and it didn't need to install anything. Before WLAK can be loaded, you must define a group for it. Oh dear. I don't know what that means. What's that mean? Okay, well. Oh, Okay, no, I do know what it. I've yeah, I know what it means. So yeah, okay. Yeah, WLAK doesn't work directly from object files. It works from a settings file. I only did this a few days ago, and I've already completely forgotten it. So we've got this here, and this is doing the work here. So this is using prog.o, which is updating. Looks a little old, but it is updating. So so this is building to prog.o. That is sort of compiling prog.o to prog build. And this is taking prog.build and building prog.hex. Okay, so why isn't it working? Okay, well let's... So we were supposed to be programming assembly, we're now programming with batch files. I apologise for this change to the expected programming, but that's the way it goes. So first test is our file. So we're compiling first test to prog.o. But prog.o hasn't updated. Doesn't look like it's updated. I don't know if that means there's a bug in it and it's silent failing, you know, bug in my code, I mean. I don't know what to make of that. I mean, you know, Scott, if you've preferred to use just regular Notepad, you could do that. The benefit of Notepad++, apart from the fact it's a better assembler, is I've got these, if I press F6, I've got this execute menu set up, and it automatically runs all my emulators. And, you know, if you wanted to use that Microsoft source code editor, I forget what it's called, there's one that's very popular now. There's no reason you couldn't use that as well. But so I find Notepad++ quite agreeable. I'd used it in the past for for PHP and things as well. So okay, well, as far as I can tell, the assembler isn't actually compiling the code, and it's crashing or failing, and it's failing silently, because that isn't creating a file anywhere I can see. I don't see where it's not created that file, and you can tell it's not created that file because we've got that error message there. Could not open the file. But where's our error message? You know, there should be some kind of, oh well, you've forgotten a, you know, I can't find this label, or you know, the syntax of this is incorrect. There should be something. You'd have thought there'd be something. So, I'm gonna guess it's that. I can't remember. It's this is a problem. I started out with ASW, and ASW wasn't great. And then I started looking at this other one, as I say, this T64 TAS, and I started learning that, and then I realised it didn't have the the ndef command or the ifdef command, and that was a problem. So now I've moved to this one. I've changed assemblers twice in one day. It's too much. It's far too much. So okay, so that does look like it's assembling now. Okay. But the Phoenix simulator seems to be running somewhere still, because it's not restarting it. I don't see it. Oh, there it is. Be gone with you. I cast you away. Okay, so yeah, this is quite frustrating. Let's see if we can get that documentation up again. So, as I say, we're looking for the command that takes the top byte of a value so that we can use it. We've got to browse this massive file. Maybe if we do it, is the search going to work this time? It managed to crash the last one. That's not going to work. Yeah, thanks for that. So power. Okay. I don't know where to look for this, so I'm just going to have to scan the entire rotten file. Assembler directives, assembler syntax, number types. Guess it's an assembler syntax. Comments, labels. Number types, strings, brackets, error messages. Yeah, we don't give error messages. We've learned that. Cartridge types, files, temporary files, arithmetic. We're counting it as arithmetic. Get low byte. Yeah, get the low byte. Get the high byte. Well, what about the third byte? How do we get the third byte? Let's go out on a limb. Maybe this will work. Maybe that'll work. But it's not like it's going to give us an error message if it doesn't. Okay, so that's something of note. I mean, this time we've got this message here saying, oh, okay, well, I've done this stuff. So last time I didn't get that. So maybe the fact that there was no success message is the failure message. I'm kind of guessing that the code I ran full-blown crashed the assembler, because, as I say, not giving an error message is pretty odd. But where's my emulator? Is it starting up? Crashed for the last time. It's still running in the background, is it? I've got this code in to check if it's already running, because with the Phoenix you don't need to restart it every time, and in fact it's so slow starting up, and it always asks you what file you want to start things, that it's actually not beneficial to so it's starting. We ran the start command here, so we're loading it again this time. So let's see if it actually ever pops up. Maybe it has started its last and we need to reboot the machine. I need to close Google Chrome there. We need Google Chrome to monitor the live stream. %, CPU, eh? Windows search is using all the CPU power for some reason. Thanks for that. Okay. Well, it doesn't look like the assembler is ever going to start up, so we'll have to enjoy that a different day, I guess. Okay. I don't know what to make of that. So, well. So what I'm going to do now, I'm not going to try and live stream the Phoenix 256 again for a while because it's like I'm having trouble with assemblers, which isn't fun to watch because it doesn't make any sense. And you know, we've got lots of groundwork to do. We need to get all of this kind of thing set up. I need some structures in place to be able to work with 24-bit numbers before I can start working with it. So what I'm going to do is I'm going to I'll work on that off camera on my faster machine when the live stream isn't using all the CPU power. I'll get some working code so that I can plot a few pixels to the screen, and then by that point I'll be a bit more comfortable with the assembler and I'll have some stuff that I can fall back on, and then maybe we'll have a look at creating a hello world where we draw a bitmap font to the screen or something. No, I didn't think it was going to be that impossible to do that on a live stream, but if I can't even get the emulator to start, which is certainly what seems to be happening at the moment, it's going to be pretty tough to actually do anything, isn't it, really? So so there we go. What are you doing? What are you doing? Nothing. That's what you're doing. Absolutely nothing. Okay, anyway, so there we go. Well, we've still got half an hour left, so let's go back to the Z80 systems. Oh, hang on a minute, this is it. Is it just waiting in the background there? Oh, that's why it wasn't starting up. Okay. So, I can't even remember what my code was supposed to be doing now. It's been waiting for that emulator to start so long. Let's have another look. Maybe we can do something then. Okay, so we're loading our triple. We were loading X, we were decreasing X, we were filling the bytes, and we were incrementing. And I don't think that command has worked. Hello, Joan, is it? Hello there. Good morning. We're trying to program the Phoenix 256, and I'm failing miserably because of a lack of experience in the assembler. Because this is a new assembler, and I don't know all of the commands, and I don't know how it works, and I'm making myself look very silly, which I hope you're all enjoying. So anyway, the assembler, it seems, was just loading up a window behind the others, and that's why it wasn't the emulator, sorry, was loading a window at the background where I couldn't see it, and that's why I wasn't able to do it. But I think at this point, even though the emulator is working fine, and it was just my misunderstanding, again, it proves to the point. I need to do a bit more groundwork and get more understanding of the setup I'm trying to use before I come back and live stream again. So I'll as I said, I'm going to get a few pixels plotted to the screen. I'll get all of the 24-bit macros and functions I like to have ready, and then we'll do that again next time. So for now, we're going to go back to this SMS bitmap example, and I'm just going to finish code commenting it and getting it ready for use in a tutorial, because this is for the Super Simple series, as I said before. So we'll finish off with about 20 minutes, something like that, of programming where we started back on this machine here. So we've got 8 lines of 4 bytes per tile, and this is the source. address of sprite data, and this is length of sprite data. Send data to VRAM. I do use the term sprite to mean any bitmap on the screen. I kind of probably should use the word bitmap instead of sprite. Copy bitmap to tile map. Yeah, maybe we'll change that to bitmap. Bitmaps, yeah, for systems without hardware sprites it makes sense, but for systems with hardware sprites, using the term sprite is it's just so we've got our bitmap data here. So this is in bit planes, so this is bit plane 0, this is bit plane 1, this is bit plane 2, and this is bit plane 3, and that because we're in 16 colours. So there we go, that hopefully will make things a bit clearer. I always struggle to explain bit planes because they're a thing that kind of, as soon as they make sense, they're completely logical, but they don't, they're not necessarily something that you're going to understand just naturally. I didn't really come across bit planes really until I started programming these old console systems, but as soon as I saw them and I read the documentation, it's like, oh yeah, that makes a lot of sense, that's fine. But I don't know whether they make sense to anyone else. I mean, the one that doesn't make sense to me is things like the Amstrad CPC in 16 color mode. You're just looking at it like, what were they doing? What were they doing? But I'm sure there's a reason. I'm sure there's a reason for it. Maybe it comes down to the way the hardware is wired or something. But as I say, at a glance, it looks very, very, very strange. But as I say, there's usually some very sensible reason for these things if you look at them from the right angle. As I say, sometimes things look crazy to the user, but the hardware was just wired in a way that was a requirement. It was the only way the hardware could do it, for speed or for some other restriction. But things like the spectrum, the way the screen memory is laid out, the 8 lines are consecutive if you increment HL, but then when you go over the 8 line boundary, you have to jump to a different memory address, and then you go over the 1/3 of the screen boundary, you have to jump to a completely different memory address again. It's really annoying as a programmer, but I'm assuming that there were very logical reasons for doing things that way. As I've said before, I think that in the case of the spectrum, I think it's to do with the 8x8 blocks of the character blocks that they wanted to be able to move quickly through 8x8 chunks, but that then messed up the rest of the address, the 16-bit addresses for the screen memory, but or something like that. But in other cases, I think it's down to the actual display hardware and the restrictions on those. But you do see these very strange things that you don't particularly like. You don't like the way things are laid out, but when you look at the hardware, it all makes some sense, I'm sure. The Neo Geo, the sprites and the tiles on the Neo Geo, the layout's ridiculous. The fixed layer, the pixels are backwards or something. I forget now. They're all jumbled up. The columns are in an odd order, and then the sprites, they go right to left, and the bytes are split into 2 ROM files, and you're just looking at it like, it looks nuts. But again, I'm sure that the hardware had a very logical reason for doing it that way. So you just have to bow to their superior knowledge and say, well, they created these very, very impressive systems back in the day when processing power and hardware was much more limited than it is now. So I'm sure they made the choices that were right at the time, even if in some cases with hindsight they weren't right, or even if to us with modern systems, they look ridiculous, you know. But anyway, so I've just been renaming these the sprite term to bitmap because, as I say, they're not sprites. And then here, so this is our filling command here. We've got our prepare VRAM command here. Palette data, fillet with tiles. That's the end. Calculate the end. Expos. The last chat message I'm seeing is hello to everybody. I'm hoping that there's not more chat messages, that my chat windows have failed to update, because that happened last time. It was someone had said hello and I hadn't replied to them, and I simply didn't see it because the chat window on my web browser had stopped updating, and then by the time I realised and moved to my phone, which had been still updating, the hello message had disappeared off the screen, so I wasn't able to say hello to that person. So I felt a bit bad about that, you know. It's like very kind of people to pop in and watch these streams and listen to me ramble on about things, so I did feel rather bad that I'd missed someone. It certainly wasn't intentional. Just curious about the Phoenix in a Bob Ross. I've already mentioned Bob Ross. Yeah. One of the developers of the Phoenix sort of dropped me an email and sort of said, hey, you know, because I didn't think there was an emulator for it, but they said, oh, well, there's this simulator, and it's like, well, you know, I don't know what you're counting as the difference between a simulator and an emulator, but I don't care either way. It works. So we'll look at it, and you know, I'm struggling a bit at the moment, but don't think in any way I've given up on it. I'll get something on it. It's just there's more challenges with it because I'm planning on doing 65816 tutorials next year, but I've not started them yet, and so I don't know anything really about the I don't know the commands so well for the 65816, and I had to change assemblers twice in about one day last week, so I don't know the syntax. I don't know what works nicely and what works badly on the assembler. I don't know the quirks of it, and it seems like there was a bug in the assembler because it looks like I managed to crash the assembler and it was silent failing without reporting that it had failed to assemble. So, you know, these are things you learn with time, and you know, everything's got bugs. You know, I don't care. There's bugs as such. You know, if I start complaining about bugs, I'll be complaining about myself most of the time because I make plenty of the things. It's knowing the limitations and the quirks. Shall we use that phrase instead? The quirks of the program you're working with, and learning how to work around them and how to preempt them. And if, as I say, in that case, it seems like, well, if the assembler fails, then it won't show any success messages, but it won't show any error either. In that particular case, I have seen error messages from it in the past, but I'm guessing that I thought the power symbol you took the top byte of something, but I think I was probably causing some kind of division by zero type error, and it was just hard failing and dropping back without an error message. So, well, fair enough. I'll bear that in mind, and maybe I can find I'll just have to make sure that doesn't happen again. So now we're just going through this and code commenting things. Define tiles command could do with some work, couldn't it, really? Set the So I don't know what sort of territories you guys are in. I don't know what areas you live in, whether it's, I'm guessing it's maybe early evening for you. It's early morning for me. It's 6:45 now, so I'll be having to finish this in about 15 minutes. I have to go to work. I have more programming to do at work. So that's, yeah, I do a lot of programming. That's what we do. Suffice to say, I don't do Z80 programming in my day job. I'll be writing CSV importers today for some software. So that's what'll be paying the bills for me today. So it's I don't know what you guys all do for a living, so to speak. I tend to find I've been doing various bits of programming over the years, ever since I was ever since I left university, really. And nothing I've ever really programmed has been very exciting or very well programmed, shall we say. I've written natty little databases, scrappy little websites and things, but never been particularly never been anything you'd print the code out and, well, evening in Texas, oh hello there, yes. I have had some dealings with I have had some dealings with America, so I should be more familiar with your time zones. It's quite fun if you've ever got a situation where you're dealing with 3 different territories, one that's the UK, one that's Japan, and one that's America. One company basically goes to sleep when the other wakes up. So you think, well, when can I reboot this server? And the answer is, well, never. You can never reboot the server. Keep it up. So it's not fun. Yes, it's the advantage of now I'm in Japan at the Japan office. It's a tiny office. Sometimes you think I need to notify the users that I've got to reboot the server, and it's one user, or maybe it's no users that day. So being in a small office has its advantages, whereas when I was in the UK, the UK office was very big, and it was like, the server's crashed. I'm about to get screamed at, aren't I? Whereas in Japan, it's like, the server's crashed. No one will probably notice. So that's certainly something I do prefer about being in the Japan office. But anyway. So I was saying that programming. There's I think there's a certain there's success to be had in doing unremarkable programming, is what I was trying to say. There's demand for it, and often people just want things. If you're working for relatively small companies, and by relatively small I don't mean very small, as I say, companies with 100 employees, they often just want things that work. They just want things that are going to work for 6 months or 2 years and will be written quickly and will do the job that was claimed and will be on time. And it doesn't matter what they're programmed in. I used to program in Visual Basic, .NET, the original one. Not the original, VB6. I've done VB6 as well. I have programmed in VB6 for my company, but VB.NET was what I mostly used to do. And I used to do Access databases, and everyone hates Access. Everyone slurs Access and says it's the spawn of Satan or some child's toy or whatever. But if you saw the Access databases that I inherited and I saw working, you wouldn't say that. And at the end of the day, it's like, well, the amount of money you have to pay for a professionally developed solution that was doing what those Access databases were doing is not trivial, and it's not money that most companies have. So the simple programming often does do the job very nicely. Right. So anyway, talking and not. So that's our function that's creating the tiles here. We could do with some more documentation on this command, couldn't we? We could do with some more. Let's move that down to here. let's not move it down. This is one of those optimization things here. Look what we're doing. We're loading HL. We're then adding HL. Instead, what we could do is we could do LB A, H, add and 38, LB. That's got to be faster, surely. Okay. Well, I've been programming for 2 hours and I'm still very tired, you know, very tired. Haven't had any coffee or any tea yet. Oh, we've broken it. We've broken it. What have we done wrong? Oh, yeah, I see what we've done. Well, yeah, I'm using B and C here, and now I don't need B and C, so yeah, that's silly. So we can all, you see, so we need to change this to L. No. Hang on a minute. Let's think this through. I'm getting a bit mixed up here. Okay, so what we need to do is we need to load in H with our Y position, which is that. And then we don't want to load in L at this point. We rotate right H. We'll rotate our B position here. And we're in our B position. We load that into A. Okay, and that wants to be down here. Does that work? Yes, it does. It looks all right, doesn't it? So we've now, well, we've not quite got rid of our use of BC here because we're still bit shifting B by 1 here. So if we'll leave that push and pop in just to protect BC, just in case our code is relying on that, I guess, just for safety. Just think if we can. So we're moving down 3 Y lines here because of the Sega Game Gear doesn't have the top lines. We're moving across 6 because it doesn't have the 6 lines. Type properly. 2 bytes per tile. I've got 5 minutes of the stream left before I have to go, and so so we're multiplying Y by 64 here. Double checking my code here, checking there's no bugs in it. I think it's all okay. So we need this in the regular version as well. So there we go. Is there anything else to put in here? Let's take these out. We're not using these anymore. Let's keep the extra code out of it, so that I was not quite sure whether to leave the print character routines in or not, because they're very useful to have if you're debugging, but if I'm trying to keep the code as simple as possible, taking them out was the thing to do. Oh, I've left that in there. Get rid of that. So as I say, I'm taking them out, but it should be very easy to put them back in if someone wanted them. And I don't know if you saw last time, the next stage of this simple series is going to be to add joystick control, and we're going to move the smiley face around the screen, and then that's probably going to be the end of the simple series. I don't think there's any point putting anything else into it, because essentially if you've got a graphic on the screen and your graphic can move and you can control your graphic via program code, then you've essentially got the basics of a game. And you know, if you've got that, then you could create a simple shoot 'em up or a simple race car game, or you know, whatever you want really. And things that are beyond that, like lots of sprites, are really just an extension of that first thing. And things like adding sound, well, if you need a simple series, if you're still on a single ASM file and you don't understand includes and how to read documentation, sound shouldn't be something you're looking at yet. It should be, you should do that kind of thing much later. And hopefully by that point you can look at my main platform specific series where we've got the chibi sound thing. And in all honesty, I think with chibi sound in most cases you could just copy paste it out of the ASM file and into your own code, and it would just work without any other includes anyway. So I'm not planning to go beyond just reading joystick input and moving a sprite, so hopefully that will be enough for people. Well, anyway, we're basically at the end of this stream. Really appreciate everyone who's been watching here. It's, you know, it's incredibly kind of you. I hope you've found some enjoyment in this. I don't know why people watch these streams. You know, I can think of various reasons you might, but I say I'm very appreciative of it. If you do have the opportunity tomorrow, the stream will be at 6 p.m. Japan time, so the opposite end of the day to this one. If you can make that, I'm sure. I think in Texas it's probably the middle of the night, but as I say, it's if any of you do get the chance to watch that, please feel free to. You know, we'll be playing some Famicom is the plan. Yep, thanks a lot. Take care, Chris. Very kind of you to say so. I'm sure my programming of CSV importers will go pretty well. If I can manage assembly coding when I'm only half awake, I think CSV programming should be pretty easy for me. Anyway, thanks for watching everyone, and goodbye.